is around 2% already. So we know where theta 1 3 is. So that's why now with more accelerated data, we are probing the CP regime. Yes.
So right now I know that delta CP is constant.
So okay, suppose.
And I also know that all these deviations are being calculated using the particular parameter.
Yes.
That delta CP comes with the middle one.
S13.
Now I change my parameterization and I put my delta CP in the either in solar sector or in atmospheric sector. And I set my detector to see the solar emission of whatever. So should I get some information about delta CP from the solar sector?
No, because what you will be measuring this CP or asymmetry. So if you do so, I told you that ultimately these angles depends on this ratio. Whatever you do, this fellow will come out the same. You have like U, E1, U, E2, the UPMNS is U, E1, E2, E3, mu1, mu2, mu3, tau1, tau2, tau3. Whatever way you multiply them, this fellow is what you are measuring. This is the physical quantity, the ratio of U, E2 by U, E1. This will always remain same. And that Yaslov invariant, at most it can flip a sign. Nothing else. This expression, this Yaslov invariant expression that I have written, you multiply in any way, you will get this expression except some sign dependence.
So in atmospheric and solar sector you cannot achieve delta CP?
No. Because there is a we are obstacled by the nature of the flux. Because in sun you have only nu e, so you will measure nu e going to nu e. It's a survival. So there is no CP comes into that picture. In atmospheric you have nu mu, you measure also disappearance of nu mu. Nu mu going to nu mu. There is no CP phase there. So you have to depend on some appearance experiment. Okay? In atmosphere, some nu mu is going to nu e, but that is hidden under the, like it's a needle in the haystack again. You have so many muon from the survival that if some nu is going to nu mu, you need to add up, right, in your detector. So you can't probe that particular part but in accelerator, if theta 1 3 would have been 0, if I am sending a beam at 300 km, start with nu mu, there will be no nu e. So you know that theta 1 3 is non-zero, and along with that then the CP part is also coming into the picture. So take home message, you have to look for the appearance of a new flavor with great dominance if you are to look for CP violation, if you want to probe the delta CP phase. Any more questions if we have? So then okay, we can wrap up for lunch. Yes. So Eddie has some announcement.
We have been able to set up the hands-on sessions. So probably the first hands-on session will be today. Now when I start the next lecture, please sign. Now here I have a request that this hands-on session I think is basically for people who are doing high energy physics or who are genuinely interested in doing high energy physics. For others it will not be particularly interesting or illuminating. People who are already working in some problem on high energy physics or some MSc students maybe are already highly motivated.